All right, all right, all right. So this is another pretty important theorem from high school geometry, and it says basically that the angle bisector splits the opposite sides into two sides that are in the same ratio with each other as the sides around it. So this dotted line, this is an angle bisector. And then it splits the opposite side into two line segments, say X and Y. The ratio between these two sides, X and Y, is the same as the ratio between B and A. So that's the statement. I have seen several proofs on the internet with similar triangles, so I think you should check that out, and I'm going to show you a different one. Okay, so I'm going to start with one that uses trigonometry, because this is for the trigonometry class right now. And so here it goes. The idea is that we're going to look at the ratio of these two areas in several different ways. So let me call this line segment here P. That would be the angle bisector. And these two angles are equal. That's what the bisector does. And so we call them theta, each of them. And now let us recall this very important, I promise this area formula to be very important. It's 1/2 A times B times sine gamma, which is 1/2 times two sides and the sine of the angle between those two sides. So we're going to apply this formula to find A1 and A2. So for A1, this side, and the angle between them is theta. So it's going to be 1/2 times B times P times sine theta. And A of 2 would be, you see, there is quite a few things in common. This line is in common, and because we are dealing with an angle bisector, the angles are the same. So it's going to be 1/2 A times P times sine theta. So when we look at a ratio like, say, A1 over A2, you will see that a lot of things simply cancel out. Sine theta cancels out, P cancels out, and 1/2 cancels out. All that we're left is B over A. So the ratio between the areas of these two triangles is the same as the ratio between these two sides. Now we're going to look at this same ratio, these two same areas, but using different characteristics of the triangle. I don't know if it's similar enough. So this is still A1 and this is still A2. But now we're going to use the good old base times height over 2. Here is one triangle. And here is another one. And if we use X and Y for the base, then these two triangles have the same height. I don't like this picture because it looks very much like it's that blue line, but it isn't. That's the height, but let us call it H, but for both triangles, it's the same height. So now A1 is 1/2 X times H, and A2 is 1/2 Y times H. And therefore, A1 over A2 is 1/2 XH over 1/2 YH. And again, lots of cancellations, and all we're left with is X over Y. So what we have proven is that the ratio between these two triangles into which the angle bisector split the original triangle into, these two areas are in the same ratio as B over A and also as X over Y. And now just cut out the middleman, and there we are. So these are the same ratios. So that completes our proof. But of course, I have something else to say. Usually, so we use trigonometry and this area formula because I'm using every opportunity I can bring up this formula for the area of the triangle. But there is a simpler way to get to this B over A, and I think it's important enough to discuss it. So And this fact that the ratio between the two areas is the same as B over A, I want to prove it with more fundamental tools. And remember the definition of an angle bisector. The angle bisector, yeah, it splits up this angle into two equal measures, but that's not the defining property, right? The defining property is that every point on this bisector is equally far from the two line segments or rays forming the angle. So these two line segments, perpendicular line segments to the sides, should be equal. This looks a little longer, so I didn't get, I'm not sure if this will help. A little better. Every point, yeah, this looks better, including this one. So if we're looking at the two triangles, A1 and A2, and we use base times height over 2, but this time we're going to use B as the base and A as the base. Well, so it happens that because of the angle bisector is what it is, these two triangles have the same height. And so then A1 is, which is this one, is 1/2 B times M, and A2 is 1/2 A times M. And then, of course, we're going to have lots of cancellations. 1/2 B times M divided by 1/2 A times M is B over A. So there is a much so we can get to this theorem well before trigonometry. So I just wanted you to know that. Thank you for watching.